be on the line and okay. Okay, let me share this PPT. Is it visible to everyone?
Yes, sir.
Okay,
Yes, sir.
yeah, that's fine. So let us start with the introduction to fluid power. So fluid power, the syllabus for fluid power actually starts after 2.5 units. Okay, the first 2.5 units are your FM, and the next 2.5 units are your FP. Okay, so in your third unit, okay, so we have the introduction to hydraulic systems, and from there we begin with the fluid power part. So what are the contents of that part B of the third unit? So we have introduction to fluid power and hydraulics. We have structure of a typical hydraulic system, symbolics for hydraulics, the control components, then we have the general reservoir system, general review of a reservoir system, and we have the introduction and basics of pumps. Okay, just a second. Okay, so I hope the voice is audible clearly.
Yes, sir.
Okay, fine. So fluid power, as we have discussed earlier, it is a process of generation, control, and transmission of power. Okay, so using fluids. So fluids basically can be subdivided into two units. That is, we have hydraulics, and the second part we have pneumatics. So in your syllabus, since we have combined the subjects, both hydraulics and pneumatics, we don't have pneumatics. So we have only the hydraulics part of it, wherein we are going to understand the systems which will be operating on use of fluids. Okay, so pneumatics makes use of compressed air. So what is the importance of fluid power? So fluid power systems, or we can say now specifically as hydraulic systems, as they are generally having a capacity to transmit equivalent power within a much smaller space, okay, than mechanical or electrical drives. So different drives of transmitting power or different types of power transmission are available to us. That is, it can be mechanical or electrical or fluid power. And in fluid power, we can have the transmission of power using a small space. Okay, we can have design a system which can transmit more power compared to the other two. Right. So, what are the basic advantages? So when we say the word fluid power, the few things come into our mind. That is simple and effective control of the system by using, or you can control the speed, the direction, the force, and the torque. Okay, using different valves. So when we say fluid power, it has a huge amount of application in industrial sectors. Okay, so it starts with vehicle braking, steering, lubrication stations. Then we have the hydraulic lifts, dump trucks, heavy machinery, and so on and so forth. Okay, so we have different applications like jack, elevators, cranes, machine tools, gearboxes, testing equipments, industrial robots, and so on. Okay, so you just can have varied applications of fluid power. Okay, so it is a major constituent of modern industries. Okay, fluid power. So what are the specific features of using hydraulic fluids, okay, or oil in case of hydraulics? The major advantage is the working. Okay, you will have a smooth working with control over the unnecessary vibrations, okay, and disturbances. So we can provide different types of movements in fluid power or the fluid power system can have different type of movements like circular, linear, automatic, and mechanical movements. Okay, so we can easily control the system, and the cost compared to other uh, types of drives is comparable. We cannot say it is less, but it is comparable. But the space that it occupies is less. That is why the applications are many for a fluid power. As and when we move on to the further part of the units, we will understand these all applications and how economic all it is. Okay. So we had discussed this. What is hydraulics? It is a combination of two words, hyder and hollows. Okay. Then the basis or the base on which this fluid power stands is Pascal's law. Okay. If you consider a closed container in which you fill the fluid, the pressure that is applied to this confined fluid by that fluid is transmitted undiminished in all directions. Okay, and it acts with equal force on equal areas. Okay, and also at right angles to the walls of the container. So with this basic law, it was thought of that if we fill a unit or a container with fluid, then if we transmit the forces to it or power, then will that power transmission be effective to perform various tasks? So with that intention, the fluid power was investigated, its applications, and so on. So that led to the revolution in the industries by the introduction of fluid power. So there are some basic properties of the fluid that we used to power the systems, or now onwards we can call the term hydraulics. In hydraulics, we use such oils which possess these kind of properties. What are those? So the oil, of course, the property is it does not have any shape. It is in neutral form. Okay, it takes the shape of the container or the unit in which we put into. Like we have in fluid power systems, we have actuators. We call as actuators. What are actuators? Actuators are those elements which will provide the movement, or they help in performing the actual work. That is by actuators. Okay, like we have rotary actuators, linear actuators, and so on. So easily we can transfer this fluid in those actuators from one location to another because of its shapelessness. Second, incompressibility. So fluids that we use should be incompressible, because if it is possible to compress this fluid, or if it gets compressed, then the transmission of power is not possible. 100% power transmission is not possible. That is why it should be incompressible. Then it transmits the forces equally and undiminished in all directions. Okay. Then what are the primary tasks? So you have gone through these 2-3 slides which I have kept earlier. That is primary task is power transmission. You can transmit you can have the movement, then you have signal transmission. Also you have some secondary tasks like lubrication, heat transport. You can transport the particles to the filter and so on and so forth. Now let us see a typical application of fluid power by taking an example. Okay, all of you know that brakes are the most important features of any moving object. Brakes are very important. So let us see a braking system which is hydraulically controlled. Okay, we call it as popularly hydraulic brake. So now, what method of teaching I have applied over here is, instead of having a monotonous, I will be speaking, let me represent or show you some videos, because beautiful videos are available on the internet which can help us in understanding the processes better. Okay, so let us understand how these hydraulic brakes work. Before we watch the video, let me just basically explain. I will use mouse, just check if I am able to point it properly. Please check, is this available, the pointer you are able to see?
Yes, sir. Yes.
Okay, done. So what is this hydraulic brake system? So suppose if you take any rotating element or any vehicle and you apply brakes. So what is that is the arrangement that is made over here. So we have something called as a brake drum. Okay, this is the brake drum or the unit which will help in stopping the vehicle. So for that brake drum, we have brake pad which is attached. Okay, so the outer element, and this inside we have the brake pad. So this brake pad will rub or come in contact with the brake drum in order to stop the movement of the vehicle. So what will happen when you press the brakes? This has an arrangement wherein you can see the force on the brake fluid is applied by pressing the pedal. So here we have the fluid that will be transmitted or supplied to this chamber. What is this chamber? This chamber is nothing but a piston and a cylinder kind of an arrangement. So once the fluid starts entering over here, what will happen? These two pistons will move apart. Okay, they will be pushed apart. So we have a connection over here. This is the brake shoe. So the brake shoe and this actuator, we can say cylinder kind of an arrangement, are connected with a link. Once we apply the brakes, fluid will start entering this unit here. It will fill this space and will push these two pistons away from each other. That is, they will come into action. Then the brake shoe will be pressed against this brake pad. So you will have this brake pad which will be coming in contact with the brake drum. So because of that, the frictional force, it will start to apply the brakes and it will stop the vehicle. Okay, so just this was just the crude idea I gave. Let us see the video and understand how actually it works. So give me a minute till I switch over from this to the YouTube link. So I will switch over to that. I have to stop sharing this PPT and I will be sharing the window which has that video. Okay, just confirm me once the video starts. Okay.
Video started, sir.
Yeah. Okay. Thank you. I will make it full screen. Okay. Just a second. Yeah. Hello.
Yes, sir.
Yeah. Did you see the video? Was it clear?
Yes, sir. It was very clear, sir.
Yeah. Now, one more time I will run the video and just I want you all to observe a few things. When the brake pad or the brake pedal was pressed, there was a fixed quantity of fluid that was stored in the upper chamber, that is the showed by blue color. So when you press that brake pedal, that fluid starts entering into that hydraulic system. So what was the hydraulic system in that? Let me just take you back to that and show you. Yeah, so if you see, you can see here at present in the regular condition where the vehicle is moving at high speed, the brake shoes are not in contact with this, the inner layer of the wheel. Okay, so there is a spring which has kept them or avoided the contact. Okay, once you press the brake pedal, you can observe the blue colored, that is the oil, starts entering into this hydraulic chamber. So you have two pistons, and at the center the oil starts pushing those two pistons. Just observe. This is the place where the oil is filled. When you apply that brake, the oil starts moving. The vehicle got stopped. The moment you release that brake pad again those two pistons will come back to the position. How they will come back? Because of the spring that is present here. It means it is a system of a single acting hydraulic cylinder which has an extension by the fluid that will pressurize it to move ahead and apply the brakes, and the retraction is controlled by spring. Okay, so it is a single acting spring retracted cylinder. Okay, that is how it works. I hope you understood. Okay, shall we go back to the PPT?
Yes, sir.
Okay, so let us go to now. Here one more link is there. That's fine. I will be keeping these links in the PPT so that somebody, if they have to watch this video once again, you can watch the video. Okay. Now let us try to understand the electronic steering system. Okay. Just as have let's have some basic idea of the electronic steering system. Just why I'm taking this is, of course, it's not in your syllabus, but if you compare a hydraulic steering system and electronic steering system, just you should know the difference, because these are the questions that they ask generally when you are out from the campus or during your campus. So how is that electronic control system, which we call it as ECS, plays an important role in your steering for high-end vehicles? Okay, generally for our smaller cars, like regular cars, we use the hydraulic steering system, but some high-end cars, or most of the high-end cars nowadays, make use of electronic steering system. Okay, wherein manual intervention is minimum. So let us see how this electronic steering system works. Okay, so let me take you to this.
I have this question for you. What do you mean by learning public speaking skills? Does
Sir,
this mean
video is not available.
Pardon?
Unable to see the video, sir.
No, I haven't yet shared. Just a second. Yeah. Purposely I did that because there will be an ad that will come, because this is all online. No, that's why. Just a second. Okay. Uh, yes. So let me switch you people to the ECS system. Are you all able to see the screen?
Yes, sir.
Yeah, just go through this, read this. The ECS or EPS, electronic power steering, also known as EPS, is electronically controlled assistance. The steering mechanism through steering assistance in terms of operational torque, okay, and to improve the driver comfort. Fine. So it helps in overall increasing the overall performance of the steering system, and it is better than hydraulic system in terms of response time and intelligence. Okay. So the driver can control the vehicle at very high speeds. Generally, what happens at high speeds, the control is lost sometimes. So that may result in mishaps. So hence, they have introduced ECS for high-end cars at top speeds. They have introduced an ECS wherein the electronic control system is in actuation up to a certain speed limit, and beyond that certain speed limit, automatically that control system will get cut off, and regular rack and pinion arrangement will get actuated to minimize the speed and maneuver the vehicle when you are taking it to the left and right. So it is just an introduction that I want you all to go through. Right? So let me start this.
बात की जाए
And
तो
of course, one more thing. The explanation for this is in our regional language. Please remember, English is just a language. What I want is you people should understand the concept behind it. Okay. So this is explained in Hindi. Let us understand this. Another point, since the syllabus of this fluid power is very minimal, we do not have any analytical calculations, nor we have any derivations, nor we have any numericals. And that is the reason I am taking this syllabus in such a manner that you should gain, so you should get some knowledge. Okay, so that is why I am showing all these videos and all other accessories. Okay, so let us watch the video.
इसे ईपीएस के नाम से भी जाना जाता है और ये जो चीज है ये एक असिस्टेंट टाइप का स्टीयरिंग मैकेनिज्म है, यानी कि जो ड्राइवर है वो जो स्टीयरिंग को कंट्रोल करता है वो कंट्रोल को ये चीज ज्यादा कंफर्टेबल और ज्यादा एक्यूरेट बनाती है। ये जो सिस्टम है वो काम करती है अलग अलग सेंसर्स के और अलग अलग एक्चुएटर के ऊपर, और इसका सिर्फ एक ही मकसद है कि जो ड्राइवर है उसका कंफर्ट बढ़ाना और उसे जो ताकत लगानी पड़ती है व्हील को घुमाने के लिए वो कम से कम लगानी पड़े। और इसके अंदर जो ECU है यानी कि इसको आप प्रोग्राम कर सकते हैं, और इसके प्रोग्रामिंग के बदौलत ये जो चीज है इसे हाइड्रोलिक पावर स्टेशन के जैसे कट ऑफ नहीं करना पड़ता, जो इसका एक बहुत ही बड़ा एडवांटेज है। बात करते हैं कंस्ट्रक्शन और कंपोनेंट्स की इलेक्ट्रॉनिक पावर स्टीयरिंग के, तो जो स्टीयरिंग व्हील है उसके स्टीयरिंग कॉलम के ऊपर लगा होगा एक स्टीयरिंग एंगल सेंसर, ये चीज ECU के साथ कनेक्ट होगी। उसके बाद आता है टॉर्क सेंसर भी ECU के साथ कनेक्ट होगा। फिर आएगा एक रिडक्शन गियर बॉक्स, यानी कि जो स्टीयरिंग कॉलम है वो इन दोनों चीज में से होके जाएगी सीधी रिडक्शन गियर बॉक्स के अंदर। रिडक्शन गियर बॉक्स के एक सिरे के ऊपर लगी होगी इलेक्ट्रिक मोटर, जिसे भी ECU ही कंट्रोल करेगा, और ECU के साथ एक एक्स्ट्रा एडिशनल सेंसर भी लगा होता है जिसे कहा जाता है व्हीकल स्पीड सेंसर। वो सेम चीज है जो आपका स्पीडोमीटर है, व्हीकल की जो स्पीड है वो बताती है, यानी कि उसकी रीडिंग भी वो देगी ECU को। और जो गियर बॉक्स है उसके आउटपुट पे लगा होगा एक रैक और पिनियन का मैकेनिज्म, यानी कि जो स्टीयरिंग कॉलम है वो सीधा आएगा पिनियन के अंदर, और पिनियन के साथ जुड़ा होगा रैक, जो कि एक नॉर्मल स्टीयरिंग मैकेनिज्म जो रैक एंड पिनियन आता है वो होगा। और रैक जो है वो डायरेक्टली कंट्रोल करेगा ड्रॉप आर्म्स को, यानी कि रैक की मूवमेंट की वजह से जो आपके फ्रंट दो व्हील है व्हीकल्स के उसकी मूवमेंट डायरेक्टली पॉसिबल हो पाएगी। अब बात करते हैं वर्किंग की विद द फंडामेंटल्स। तो एक एक कंपोनेंट की बात की जाए तो जो व्हीकल स्पीड सेंसर है वो क्या करेगा कि जो व्हीकल की स्पीड है वो स्पीड को मेजर करके कॉन्स्टेंटली जो ECU है उसे सिग्नल देता रहेगा कि व्हीकल की स्पीड जो है वो इस कंडीशन के ऊपर ये है। जो स्टीयरिंग एंगल सेंसर है वो ECU को सिग्नल देगा कि जो स्टीयरिंग व्हील है वो कौन सी डायरेक्शन के अंदर कितनी डिग्री मुड़ा हुआ है। उसके बाद आता है टॉर्क सेंसर जो स्टीयरिंग के ऊपर ड्राइवर के द्वारा जो ताकत लगाई जाती है, यानी कि किस स्पीड के अंदर स्टीयरिंग व्हील घूम रहा है, किस ताकत के साथ घूम रहा है, उसकी जो इंफॉर्मेशन है वो देगा ECU को। और लास्ट में जो इलेक्ट्रिक मोटर है वो कंट्रोल की जाएगी बाय मींस ऑफ ईसीयू कि कब उसको स्टार्ट करना है, कब उसको स्टॉप करना है। अब जब आप स्टीयरिंग व्हील को घुमाते हैं तो तीनों सेंसर डेटा देता है ईसीयू को। ईसीयू सिलेक्ट करता है कि मोटर चलेगी या नहीं चलेगी, यानी कि आपके पावर के साथ अगर ज़रूरत होगी तो इलेक्ट्रिक मोटर अपना पावर ऐड करेगी, अगर ज़रूरत नहीं है तो वो पावर ऐड नहीं करेगी। और जो रिडक्शन गियर बॉक्स है वो घुमाएगा पिनियन को, पिनियन के साथ मूवमेंट लेगा रैक, और इससे आपका जो व्हीकल है उसको डिजायर डायरेक्शन के अंदर टर्न मिल पाएगा। बात करते हैं एक्चुअल वर्किंग की, तो ये एक रियल टाइम वर्किंग है। आप देख सकते हैं सेंसर्स जो है बॉडी जल्दी ही डिटेक्ट कर लेते हैं, और विद द फ्रैक्शन जब आप स्टीयरिंग व्हील घुमाते हैं तो आपके व्हील भी उसी के साथ वर्क करते हैं। तो अब बात करते हैं एडवांटेजेस की, तो ईपीएस का फर्स्ट एडवांटेज है कि ये चीज़ बहुत ही कस्टमाइजेबल है। आपको सिर्फ ईसीयू का प्रोग्रामिंग चेंज करना है और इसके मुताबिक आपका जो स्टीयरिंग है उसका असिस्टेंट रिस्पॉन्स है वो भी साथ ही बदल जाएगा। एडवांटेज है वो है कि भाई ये सिस्टम जो है वो हाईली एफिशिएंट है, ना ही कि हाइड्रोलिक पावर स्टीयरिंग की जैसे कि हर दम पंप जो है वो चलता रहता है। यहाँ पे जब जरूरत होगी तभी इलेक्ट्रिक मोटर है वो पावर यूज करेगी, यानी कि हाइड्रोलिक पावर सिस्टम वाले जो पावर स्टीयरिंग वाली कार है उससे जो ईपीएस वाले सिस्टम है उसका फ्यूल कंजप्शन रिलेटिवली बहुत ही ज्यादा लो रहता है। अब बात करते हैं तीसरे एडवांटेज की, कि जो फेलियर का टाइम होता है, यानी कि अगर आपका ईपीएस है जो स्टीयरिंग है वो सिस्टम अगर फेल हो गया बाय मींस ऑफ एनीथिंग, तो जो रैक एंड पिनियन मैकेनिज्म है सिंपली काम करता है, उसे जो गियर बॉक्स है वो डिस्कनेक्ट कर देगा पूरे ईपीएस सिस्टम के, यानी कि आप जो व्हीकल है उसे कंट्रोल कर पाएंगे डायरेक्टली बाय मींस ऑफ रैक एंड पिनियन, और जो ईपीएस का पावर स्टीयरिंग का जो मैकेनिज्म है वो कंप्लीटली डिसेबल हो जाएगा बाय मींस ऑफ गियर बॉक्स, और वो आपका नॉर्मल स्टीयरिंग के अंदर किसी भी प्रकार का इंटरफेरेंस नहीं करेगा। ऐसे मैंने वीडियो के स्टार्ट में पूछा था ये।
Yeah, one second. I did a small mistake here. I wanted to show you all the hydraulic power steering system first, and then we could have compared it with electronic power system. Okay, so never mind. I will be now having the hydraulic power system video. Just watch that and compare it with electronic power steering system. So you have just seen the electronic power steering system. Let me take you to that.
नमस्कार दोस्तों, स्वागत है आपका द ऑटोमोटिव के लिए इंजन के पास।
Yeah, once again. Are you able to see this?
Yes, sir.
Okay, now just have a look at hydraulic power steering system, which makes use of your fluid. Okay, generally this was implied or applied to mechanical steering system when it was observed that the driver has to put in a lot of effort in order to turn the vehicle and control the vehicle. Okay, so you might have observed that in case of heavy vehicles, the hydraulic power system plays a very important role. Okay, you might have observed how the public transport buses and all, so it was earlier very difficult to maneuver the vehicle or control or steer it. So that is why these hydraulic systems were introduced. So it will avoid the toppling and rollover at high speeds. Okay, so let us now understand this hydraulic power steering system.
पावर का भी यूज करता है, यानी कि अकेले ड्राइवर को पूरी ताकत नहीं लगानी पड़ती। तो हाइड्रोलिक पावर स्टीयरिंग जो है वो क्या करता है कि ड्राइवर का जो एफर्ट है उसे कम कर देता है, और इसे इसलिए लगाया जाता है ताकि जो ड्राइवर है उसे जो स्टीयरिंग के लिए ताकत लगानी पड़ती है वो कम लगानी पड़े। और इसके अंदर एक डिसएंगेज का फंक्शन भी होता है ताकि हाई स्पीड के अंदर जो व्हीकल है उसके व्हील्स है वो जरूरत से ज्यादा तेजी से टर्न ना ले ले। तो बात करते हैं हाइड्रोलिक पावर स्टीयरिंग के कंस्ट्रक्शन की, तो जो रिजर्वियर होता है उसके साथ कनेक्ट होता है ऑयल पंप, ऑयल पंप के साथ जो है कनेक्ट होता है डायरेक्शन कंट्रोल वाल्व। ये एक 4 वे डायरेक्शन कंट्रोल वाल्व है, यानी कि इसके 4 टर्मिनल होंगे। एक टर्मिनल है वो ऑयल पंप के साथ जुड़ा है, उसके सामने वाला जो टर्मिनल है वो रिजर्वियर में रिटर्न लाइन की तरह आता है। जो टॉप और बॉटम यानी कि जो अपोजिट टर्मिनल है वो दोनों लगे होते हैं एक डबल एक्टिंग हाइड्रोलिक सिलेंडर के अंदर। ये जो वाल आता है ये उसे स्पूल टाइप वाल कहा जाता है, और जो पंप है वो एक्चुअली में एक रोटरी टाइप का हाइड्रोलिक पंप होता है, और जिसे ऑयल पंप भी कहते हैं। अब जो सिलेंडर है उसकी बात करें तो सिलेंडर है जो फ्रंट 2 व्हील है उसके साथ कनेक्ट होता है, यानी कि जो टाई रोड आता है टाई रोड की जगह पे ये जो हाइड्रोलिक सिलेंडर है उसकी रैम्प को एक्चुअली में फिक्स कर दिया जाता है। बात करते हैं हाइड्रोलिक पावर स्टीयरिंग के वर्किंग की, तो पहली कंडीशन के अंदर आप कोई भी इनपुट नहीं
Uh, this is the first condition wherein you are at a high speed and you are moving in a straight direction. Okay, so you don't want the wheels to be turning to the left or right. So let us see.
दे रहे हैं स्टीयरिंग व्हील को।
One more thing, you have all these control. We used to talk regarding a hydraulic system, right? So what all is the component of that hydraulic system? You can observe the reservoir. You have the pump. Here before that there will be a filter that will be fixed here, which will be connected. Now the oil will flow to the DCV. From DCV you have a control of the flow of the oil, and here we have the actuator. So this is actually a typical cylinder in which a piston has been fixed, and these two are connected to the wheels. Okay, so let's see how it works.
और जिसके कारण जो डायरेक्शन कंट्रोल वाल है वो टॉप चेंबर और बॉटम चेंबर, यानी कि जो टॉप लाइन है और बॉटम लाइन है हाइड्रोलिक सिलेंडर की, उसके अंदर कोई भी ऑयल नहीं जाने देगा, यानी कि टॉप लाइन बॉटम लाइन दोनों के अंदर सेम प्रेशर रहेगा, जो क्या करेगा कि जो हाइड्रोलिक सिलेंडर की रैम है उसे किसी भी डायरेक्शन के अंदर मूवमेंट नहीं करने देगा, जिसके कारण आपके जो व्हील है वो कंप्लीटली स्टेडी एक पोजीशन के अंदर रह पाएंगे। बात करते हैं दूसरी कंडीशन की, जिसके अंदर आप अपनी कार को लेफ्ट साइड के अंदर टर्न कर रहे हैं, जिसके अंदर क्या होगा कि जो स्पूल वाल है वो ऑयल पंप को डायरेक्टली जो लेफ्ट साइड का चेंबर है उसके साथ कनेक्ट कर देगा, यानी कि जो ऑयल पंप है उसमें से प्रेशराइज ऑयल जो है वो लेफ्ट चेंबर के अंदर जाएगा, जो रैम को राइट साइड की ओर धक्का मारेगा, यानी कि जो राइट साइड का चेंबर था उसका जो ऑयल है वो वाया रिटर्न लाइन फिर से रिजर्वायर के अंदर पहुंच जाएगा, और जिसके कारण आपके जो व्हील है वो लेफ्ट साइड के अंदर टर्न मारेंगे और आपका जो व्हीकल है वो लेफ्ट साइड के ऊपर टर्न लेगा। अब ये
Just if you observe, when we were explaining in the lab, we have the connections as P to A and T to B. So where are those P to A? P is the pump, A is the first movement, that is extension of the cylinder, and what is that B to T? B is nothing but this side, wherein from the blank end the oil will move back to the tank. Okay, P to A and B to T. This is how is the connection, and the reverse which you can observe during the vehicle turning towards the right side. Let's see that. So in reverse, what will happen? You will have the cross connections. You people were drawing in that circuit diagram, right? Cross arrows. So your connections will get changed. Let us see that.
ये जो मूवमेंट है व्हील की और रैम की वो एक्चुअली में कंट्रोल होती है ईसीयू के द्वारा, यानी कि जो ऑयल पंप है उसको कंट्रोल मिलता है ईसीयू की ओर से। करते हैं तीसरी कंडीशन की, तो तीसरी कंडीशन के अंदर जो व्हीकल है उसे राइट टर्न लिया जा रहा है, तो इस बार जो स्पूल वाल है वो ऑयल पंप को कनेक्ट करेगा राइट साइड के चेंबर के अंदर, जो कि रैम को पुश करेगा लेफ्ट साइड की ओर, और जो लेफ्ट वाला चेंबर था उसका जो ऑयल है वो धीरे धीरे रिटर्न लाइन से नीचे पहुंच जाएगा रिजर्वायर के अंदर, और आपका जो व्हीकल है उसके व्हील है वो राइट साइड के अंदर टर्न ले लेंगे, और जिसके कारण आपका जो व्हीकल है वो राइट साइड के अंदर विदाउट मैनी मैक्स एफर्ट टर्न ले पाएगा। तो अब बात करते हैं पावर स्टीयरिंग के कट ऑफ सिस्टम की, तो यूजुअली जो मेजॉरिटी ऑफ व्हीकल है उसका पावर स्टीयरिंग 30 किलोमीटर प्रति घंटे से 40 किलोमीटर प्रति घंटे के बीच में कट ऑफ हो जाता है, जिसका मेन कारण ये है कि अगर आप हाई स्पीड के ऊपर जा रहे हो तो आपका जो व्हील है स्टीयरिंग के पहले दो व्हील है अगर वो जरूरत से ज्यादा तेजी से टर्न ले गए तो आपका व्हीकल रोल ओवर होने की संभावना ज्यादा है। जब कट ऑफ होता है तो क्या होता है कि हाइड्रोलिक सिलेंडर का जो पंप है उसे ईसीयू एक्चुअली में बंद कर देता है, और उसके साथ जो नॉर्मल रैक एंड पिनियन स्टीयरिंग लगा होता है वो एक्शन के अंदर आ जाता है, और उसके मदद से आप अपने स्टीयरिंग को कंट्रोल में ले सकते हैं। बात करते हैं हाइड्रोलिक पावर सिस्टम के एडवांटेजेस की, तो ये ड्राइवर का जो फटीग है, ड्राइवर को जो ताकत आजमानी पड़ती है वो कम कर देगा। जो
Just to add over here, you might have observed that when you are traveling at a high speed, maybe 80 kmph, suddenly if you want to control the steering, you may feel that jerk, you'll feel heavy. Sometimes we get frightened, like suddenly if there is a turn that comes along and you have to control. So that jerk you feel because the ECS system will cut off that connection, and the regular rack and pinion arrangement will get actuated in order to avoid the rollover as explained. Okay. Now let us see the advantages of this system.
व्हील है उसके ऊपर से जो रिटर्न लोड आता है उसे कम कर देगा, यानी कि आपको स्टीयरिंग व्हील के ऊपर ज्यादा वाइब्रेशन नहीं मिलेंगे। और जो लास्ट है उसका मतलब ये है कि हाइड्रोलिक जो स्टीयरिंग है, जिसके कारण जो हैवी ड्यूटी व्हीकल्स है उसके अंदर ड्राइवर को जो स्टीयरिंग घुमाने में तकलीफ पड़ती है वो तकलीफ कम हो जाती है, और जिसके कारण जो ड्राइवर है वो लंबी ट्रिप के ऊपर कंफर्टेबली जा सकता है। ऑटोमोबाइल के रिलेटेड
Yeah. So I think we can take a short break here. Okay, and we will be joining back after 10 to 15 minutes. Okay, now it is 10:54 in this PC. So let us join back by around 11:10. Okay, then we will take up the next theory part of the chapter, which will start with the control components and all that theory part. So I want you people to see more of the informative videos as well as the knowledge that you gain from these, because theoretical part I know you people will be studying. So to make it more interesting, we have added these videos and all, okay, and animations which we have in the next chapter. So we will meet after around 10 minutes. Okay. If you want to put some comments, some feedback or something, you can put in the chat box. That will be fine for us. Okay. Uh, Hello everyone. I hope all have joined back. Shall we start? Hello.
Yes, sir.
Yeah. Let me go back to the PPT. I hope the PPT is visible. Make it full screen. Shall I start, Abdul? Okay. So let us understand now the next component of your syllabus, that is a hydraulic circuit. So how do you define a hydraulic circuit? A circuit is basically a system, okay, which comprises of number of elements, or you can say interconnected set of discrete components. These discrete components will help in transporting the fluid from one component to the other. Okay, all these components together, individual components together, comprise of a circuit. Okay, so what are the components of this hydraulic circuit? So we have the first five. Actually, the first five themselves are the control components. You have the reservoir, which is the source for storing that hydraulic fluid, that is your oil. Then we have the pump, which we call it as the heart of the hydraulic system or part of the circuit, which will transport the fluid initially from the tank to all the other elements of the hydraulic system. Then we have the actuator. So the actuator is nothing but your hydraulic cylinder. Then we have the piston, a part of the actuator, which will help in moving the fluid on the either ends. The last is control valves, or relief valves, or you can have the lifting arms. So these are the valves which will help in controlling the direction, the flow rate, and so on and so forth. So you can explain these components of a hydraulic system. So generally they ask a question like sketch and explain the components of a hydraulic system. So you are supposed to draw this sketch. Okay, don't draw the hydraulic circuit diagram. You need to draw this system. When they say system, you please draw this. So you can see that if you want to understand the operation of this hydraulic system, you have the reservoir here, which is connected to the filter. So you can observe that there is a filter before the pump so that the oil is clean.
Excuse me,
And
sir.
yeah,
Sir, the PPT is not visible, sir.
all right. One second. Sharing. I think the sharing was the video sharing was there. Just a second. Yeah. Mm. I'm sorry. I think we were sharing that video. Now see, is the PPT visible?
Yes, sir, it's
Yes, sir.
visible.
Now,
Yeah. Okay. So we had just saw these two slides. So the circuit and the hydraulic component. So if you see the hydraulic component or hydraulic system, you are supposed to draw this diagram. Okay. Don't draw this circuit diagram because we uh, we will be using these circuits when we draw the circuits. Okay, maybe in the lab or in the fifth unit. But when they say sketch and explain a hydraulic system, we are supposed to draw this sketch. You can see that the circuit, or sorry, the system consists of these elements. You have the reservoir or the oil tank, from which the oil is taken into the filter. The filter will clean the oil and then send it to the pump. Okay, so from the pump you will have the pressure regulator, which will control the pressure as we were setting the pressure 10 bar, 20 bar, 30 bar, and so on. From there, the oil will be sent to the DCV, directional control valve. Okay. From the DCV, it is taken into the actuator to perform the work, that is to lift the load, lower the load, and so on. And you have a PRV which will be fixed, which will help in relieving the pressure if there is excess pressure over here. So that is not shown here, but you can see this circuit diagram in which it is shown. Okay, so these are the elements of your hydraulic system or components of a hydraulic system. So if the question is asked for 10 marks, sketch and explain the components of a hydraulic system, you are supposed to draw this sketch, which may consist of 5 marks, and you have to explain those 5 components like reservoir, filter, pump, DCV, and the actuator, for which you have 5 marks. Okay. So the functions of each of these control components are as follows. So we have the pump, which is used to move the fluid from one part of the system to another. Okay, it is the heart of the hydraulic system. So what type of hydraulic fluids that we use generally? We had seen this earlier during our lab session. So just highlighting this once again. Then we have the actuator, which we call it as hydraulic cylinder. The main function of the cylinder is to convert hydraulic power into mechanical force. Okay, maybe linear, rotary, and so on and so forth. So what are the types of actuators that we use? They are your cylinders. So in cylinder, we have again different types of cylinders. You people don't have this for your syllabus, like types of cylinders, but we have general understanding of single acting, double acting cylinder. Okay, so we have ram cylinder, single acting, telescopic, spring return, and double acting cylinder. Spring return you have seen. You will connect the spring to the all over that rod end, and you will have the retraction stroke, which will happen because of the expansion of the spring. During extension stroke, the spring would have been compressed with the flow of the fluid, and retraction will be spring actuated. We will see that. Okay. Next, we have the valves. So you can write about the valves in brief. Like what are the types of valves? DCV, PCV, and FCV, which controls the direction, the pressure, as well as the volume or flow control. Now we have some symbols. Okay, so again a question may pop up like explain the different symbols used in a hydraulic circuit, so or a system. So you can show any of these few symbols. There are many symbols. Okay, very few have been shown in for these two slides. So this is slide number 1, in which we have the piping, which we can show by a straight line. We have a pilot line. Pilot line means whenever necessary, it will get actuated. Okay. Then we have the cross lines, which show the pipes or the connections, the connected lines. We have the pump, we have the motor, the reservoir, filter. We have devised these symbols. They have devised these symbols in order to minimize the work of drawing those components every time. So when you want to have a drawing of a hydraulic system, instead of having a detailed drawing, we can use these symbols. Okay. So you can see the cylinder, like this is a double acting cylinder wherein you have two connections. If this was missing, then it would have been a single acting cylinder. There will be a spring over here. Some more symbols. You can observe the types of symbols and the differences in that. So if it is a pump, then we have the vertex of this triangle, which is a filled triangle or arrow. It's touching the circumference of this circle. And here you have the base of the triangle touching the circumference. Okay, so the difference here, both seem to be very same, but you have the difference. Fine. So pump and a motor. Next, similarly, if it is hydraulics, then these triangular arrows will always be filled. Okay, shaded, dark inside, completely filled. If it is pneumatics, then it will be definitely open arrows. That is, it will be unfilled. Fine. So you have the single acting cylinder representation. This is single acting cylinder without spring. This is single acting cylinder with spring return. So oil will flow here. It will push the piston and it will compress the spring. This is extension stroke. For retraction stroke, it will be spring actuated. Similarly, we have so many symbols here. You can draw any of these symbols. In general, you can draw some symbols and explain. This is a big list because it has also pneumatic symbols: accumulator, spring loaded, gas loaded, weight accumulator, and so on. So few of them you can show. Then the applications of fluid power, you had seen this slide also earlier. I have retained that, so it will be used for various applications. Now, why I am keeping these slides is because you have to answer the questions in the examination. Explain the different applications of fluid power, like machine tools, transfer lines, lifting and conveying devices, metal forming processes, rolling machines, lifts. You have seen the difference between traveling in your regular mechanical lifts and hydraulic lifts. You don't know in hydraulic lift when the lift started and when it reached the top floor. So the transition or the movement is very smooth, okay, with the non-jerky movement, right? So that is how you can understand the applications of fluid power. So many applications are there. These are very few. Mobile hydraulics and so on. So the advantages of fluid power, general advantages like multiplication of the forces, then multifunction control, can control the speed, low speed, torque, they are economical, low weight to power ratio because the units are smaller, the weight is less, and they can transfer more power. That is possible. Okay, then we can be used where safety is of vital importance. Okay, compared to hydraulic pneumatic systems, hydraulic systems are quite smooth in operation. Okay, so that is how it goes. Next, the last bit of this unit number 3 is your reservoir system. So reservoir is one of the important components of a hydraulic system, wherein a finite amount of liquid, okay, is stored and reused continually as the circuit works. Okay, so the hydraulic circuit, it's a part of the hydraulic circuit. Okay, it can be a part of the framework or it can be a separate standalone unit. Okay, reservoir can be placed somewhere and the connections can be given from there. In either case, the design and implementation is very important. So what can be the question onto this? They can ask you a question like, sketch and explain a typical reservoir system for a hydraulic circuit or for a hydraulic application. So typical reservoir system can be explained with this diagram. Okay, you are supposed to draw this diagram. So please practice this diagram. It's a simple diagram wherein you have the different elements like from the start. If you see it, this is a intake chamber. In the chamber we have the hydraulic fluid that will be continuously stored, and there will be a level indicator here. So how much of the tank is filled with the oil. Okay, so you have the intake chamber. Then from here we have the pipe, which is the intake pipe in which the fluid is sucked inside. How the suction happens? Because of the pump. How the suction happens in the pump? Because of the suction pressure. And what happens? The suction pressure is generated because of the moving elements in the pump. We will see that. Okay, we will see that further, how the pump works and principle of operation of pump. So the oil is sucked inside, but you can observe here there is a filter that is kept in between. So clean oil is taken inside the pump, which will be sent to all the other elements. You can see there is an arrow. They have not shown all other elements. This goes to the DCV, then from DCV to the actuator, performs the work, and there will be a return filter. So one line from the other side, if it is a double acting cylinder, from the other end will come back to the return filter, and again the oil is filtered here. Please remember, clean oil is sucked in and clean oil is returned back to the tank. In spite of this, if there is any dust particle that gets embedded, it is cleaned. Okay, and you have the settling plate, okay, to avoid the what do you call, the turbulence or so. You have the settling plate which can be used. You have a drain plug here if you want to drain the oil. Then you have a cleaning door. You can remove this door and you can clean the entire hydraulic tank. And you have a ventilation port. And you have the level indicator and so on and so forth. So these are basic elements of a typical reservoir system. Okay. So till here, what we have studied, starting from definition of hydraulics or definition of fluid power, then we have the applications of fluid power, advantages of fluid power, Pascal's law. Then you have the typical what do you call, control components of a hydraulic system and reservoir. So till reservoir completes your unit number 3. So half unit we have covered today, that is unit number 3. Okay, so we will be having the next parts which will be control components in a hydraulic system. That is your unit number 4. Now what has happened is, unfortunately, I don't know, during framing of the syllabus one mistake has happened. This syllabus was framed, I think, in the year 2016. So the professor who had done it, I think there is a mistake from his side, that they have eliminated the most since the syllabus was very heavy, because they merged two subjects, fluid machines and fluid power. They have removed this pump and the concepts of pump. You know, pump is being the heart of the hydraulic system. As you know, this is the heart of the hydraulic system. As you know, it should have been included as the study of pump, pumping theory, types of pumps, what are the different categories of pumps, and so on. But that has been eliminated. However, just for our information sake, there will be no questions that may come on to this, but you people should know. They may ask you, what is a pump, how does it operate, what happens in a pump, and so on. So let us take up few bits. Yes, sir, fluid power. हाँ sir, 7. Just a second. Yeah. A, B, C, D ಎಲ್ಲ parallel sir. ಮಂಜುನಾಥ್ ಒಂದ್ ಕಡೆ ತಗೊಳ್ಳಿಕತ್ತಾರ. Yes. Yeah. Sorry for the disturbance. So we have this pumping theory, and in this pumping theory, we are going to understand how the pump works. So if you see here in this, is this animation visible to you people? Can anyone reply?
Yes, sir.
Yeah. Okay. So you have this animation in which you have a rotary element to which a connecting rod has been attached, and the conversion here, what is happening is this rotary motion is converted to reciprocating motion. Okay. This is a piston and a rod arrangement. So what is happening here in a pump, the design is like you will be having two valves, okay, inlet and outlet. Okay. So if you see the yellow part and this brown part, so for half of the revolution, if you observe, the piston will be moving from, let us take this as LHS and let us take this as RHS. It will be moving from RHS to LHS. During this, what happens is, this valve will be closed and this valve will open up. So what will happen? You will suck in the fluid, because as the piston moves to the LHS, there will be suction that will be generated here due to the pressure difference, and the oil is taken inside for half of the revolution. For the remaining half of the revolution, what will happen? Once the piston starts moving from LHS to RHS, this valve will get closed. It will be seated back in its position because of the arrangement that is over here, and the oil will start entering up. It will have no space to come out here, so it will start entering up. So every time a fixed quantity or volume of fluid is sucked inside and the same quantity of fluid is pushed outside. Such kind of pumps which can deliver a fixed volume of fluid or liquid are called as positive displacement pumps. So that quantity of oil that is taken in and pushed out to the further part of the hydraulic system is fixed. That is what we call it as positive displacement pumps. Okay, this is what is the pumping theory. Please remember this. Now, this movements, what you observed here, at present we have this system which we have a kind of a reciprocating pump. Okay, so it is a reciprocating pump. Yeah, reciprocating piston pump, wherein the piston movement creates the suction pressure and discharges. Okay. Similarly, we can operate, or this theory of pumping can be mechanized, or we can use different kinds of elements. Like if we use gears, can we have two gears, and because of the movement of these two gears, can there be a suction pressure that can be generated and we can displace the fixed quantity of or volume of fluid? Is it possible? Yes, definitely possible. So the next we have here is the types of pumps. Just observe this. Yes, this is what is a gear pump. Okay, in this animation, you people can see that two gears which are meshed with each other are rotating continuously. And if you observe carefully, the left envelope, this is suction, and that same fluid is carried in the ports here in the annular spaces between the gear teeth and this casing. So that space is filled with oil every time, and that amount of oil is discharged. Okay, suction, discharge to the further part of the hydraulic system. So such kind of pumps which operate by the meshing of gears externally is called as external gear pump. Okay. Similarly, you can see another diagram wherein external gear pump works like it will suck the fluid inside, carry it all along the annular spaces and push it out. So that kind of pumps we call it as external gear pumps. Similarly, we can have an internal gear pump. So this is another diagram for external gear pump. You can see at the lower side, you have the suction that is generated. Why suction is generated here? Because it will be like a what do you call a diverging section wherein the two gears are moving away from each other. So there is suction that is generated, and once suction is generated, oil is taken inside, and at the other end, when where the two gears are meshing with each other towards each other, and they are creating a kind of a converging channel. Okay, so it is creating, it is pushing the oil outside. Fine. So that is how it works. Similarly, we have an internal gear pump. You can see the meshing of the gear system is internal. So you have one gear which is fixed on the shaft here, which is eccentric. Fine. So why it has been made eccentric is because it has to make space for another element here, which we call it as a crescent seal. What is seal? Seal is nothing but which will define the intake and the outlet, or you can say inlet and outlet. If you observe at any point of time, this space wherein, or this portion wherein the two gears are meshing out from each other, again here a suction pressure is generated. Okay, because of increase in the volume, the oil is sucked inside, and when this oil is carried all along this length here also as well as here also, at the other end you can see that the gears are meeting with each other, towards each other, and they are connecting with each other. So there is a push that is given to that fluid. So that is discharge, suction, discharge, and there is a crescent seal in between. Of course, you people had in the earlier syllabus, this was a complete study. Also, we had the numericals wherein you people were supposed to calculate the discharge and the volumetric efficiency, mechanical efficiency, overall efficiency. Unfortunately, you don't have that analytical part. Okay? So since it is not there in the syllabus, we can just discuss it, but we cannot have it in your CI as well as SW. Okay. So next is piston pumps. You know, there are some piston pumps are of two types. One is axial piston pump, one is radial piston pump. So if the reciprocating of the piston is along the radius of a rotary element, then we call it as the radial piston pump. Similarly, if it was axial, then it would have been a axial piston pump. So just you can observe these animations and understand, or you can tell at least if somebody asks what are the types of pumps, maybe in your placements and all. Okay, so like that, we have many of them: screw pump, lobe pump, vane pump, and so on, which are not there. So I'm not putting that all in the PPT. It should not create a confusion. Okay, next, the last bit for today, which we will be taking, is your actuator. So what are the, again here, unfortunately, we don't have this as a part of the syllabus because we don't have the theory part of the actuators, like sketch and explain a linear actuator or a rotary actuator and so on. So let us just understand some basics of this actuator. So if you observe, you can see this is a simple single acting cylinder. I was telling you people. Of course, he has shown here air in and exhaust for a pneumatic, but the same principle is there for hydraulic. You can observe here. There is a spring which is connected at the rod end of the cylinder, and this is the blank end of the cylinder wherein oil is taken or sucked inside. Okay. Once the oil starts entering, this piston will be pushed ahead, and it will move from LHS to RHS, or we call that stroke as a extension stroke of the cylinder, wherein the work is done. So it is extension by the oil that fills in that space, and retraction by spring expansion. So spring return single acting cylinder. So this develops the thrust in only one direction. Okay, so the piston will return back by a spring. Okay, that is what is a single acting cylinder, which we call it as. Okay, so here a spring which has to be shown is missing, so oil from the pump will enter and will return back from the during the retraction. Single acting cylinder, few advantages and disadvantages you can remember if asked, in case if asked. So this has lower fluid consumption compared to double acting, because in double acting we have the oil filled at both the ends. Then this can make use of valves with regards to the valves to control the direction, flow, or so on. So we can use three-way valve instead of four-way valve. And disadvantage is reduction in the piston thrust. You cannot use it for very heavy loading and all. Thrust is less, and longer length of the body due to springs. So spring occupies more length. Next one, double acting cylinder. So in case of double acting cylinder, thrust is developed in both extending and retracting directions as the pressure is applied at appropriate ports. So you people remember we used to tell that P to A and T to B to T. Okay. So here you can see this is the piston, this is the piston rod. So oil must be present here. It should be filled here completely. Similarly, oil should be filled here, but please remember the area that it has to fill during extension is more compared to the area that the oil has to fill during retraction. That is why, if you remember, we had asked a question to you all, like why the retraction is generally faster, okay, than the extension. That is because the area of rod has been subtracted in this total area during retraction. So the oil will fill faster and it will have the faster retraction. But during extension, it will take time, because as this piston moves ahead, complete area has to be filled with the oil. Okay. So here, in case of double acting cylinders, you have a more thrust that is applied and a more compact body when compared to single acting. Higher forces with smaller bore size. Okay. There is no spring over here. So you can have complete loading during extension as well as retraction. But what do you call, disadvantage is that the force on retraction is different from the extension due to the reduced surface area where the piston rod attaches to the piston. That is what we discussed. Because of the area difference, the force differs. That is one of the disadvantages of double acting cylinder. If you see actually how the cylinder looks like, if you see the construction, this is how it will be looking like. So you have the seal, you have the sealing components, because sealing is very important in case of any hydraulic system. There should not be any leakage. Okay, if there is a leakage, then the energy or the power is lost. So you have these different elements of the double acting cylinder. So the next, that is the type of valves, or this is your unit number 4. We will be starting in the next week. So this unit is very lengthy and it will take some time. Okay, so we will have this in your next class. That is, I think we will be meeting on next Thursday. Okay, so any doubts, anything to be shared or discussed, you can please open up, or you can also type in the chat box. I hope all are there. Yeah, I'm just clicking on this attendance. I took the attendance just now. Any other doubts? I hope this method of delivery was okay with you all. And every time we will be doing the same. We will have the PPT, but as a part of the PPT, there will be videos and animations that will be embedded, because that will help you people really. Okay, if there are no doubts, I think we can wind up. Okay, so let us meet again on next Thursday. Please remember the links, and I hope next week it will be perfect, because this week is an introductory session, so there was some small confusion. Anything, if it is there, please let me know. You can WhatsApp personally if something is to be added to the PPT or whatever it is. Okay. So similarly, we will be having the further classes of fluid power by me, assisted by SR Kulkarni sir, and fluid machines will be taken by Manjunath sir. And we will upload these videos, okay, like today's video, recorded videos on the Google Classroom, or we will share the drive link with you all, okay. So see to it that you go through the videos and prepare for your examinations. Is it clear? And also, we will be sharing the soft copy of 2 books. One is Fluid Power by Anthony Esposito, and another is by Fluid Power by Andrew Parr. These two books are really good, and you can prepare your own notes. Now I feel, being in 7th semester, I feel that you people are matured enough to prepare your notes. If we can give you the textbook, I'm sure you people will prepare the notes, and prepare the notes not in the form of paragraphs. Please prepare the notes in the form of points, especially for fluid power. Because if I ask you sketch and explain the control components of hydraulic system, see to it that you should have a perfect sketch, neat sketch, followed by 6 to 7 points. That's enough. Don't write big pages, okay? And simply waste your time, and it will be cumbersome for us to read those in between the lines what you have written. Simply write pump, what is its function, reservoir, what is its function, control valves, what is this function, 1, 2, 3, 4, 5, 6, and that's the end of it. You will get 10 out of 10. Clear? Okay, so we will meet up in the next class. Thank you. Bye-bye for the day.
Thank you, sir.
Okay.